Rank order method, part 36. In part 35, I have covered rank order method, theoretical part of the rank order method. Now in this part, I have taken example. Calculate the coefficient of correlation by the rank order method from the data given below and interpret the result obtained. First is students name are given, or student by number is given. 1 2 3 4 5 6 7 8 students are given, and in two subjects, mathematics and physics, they have scored separately. Marks are given in two different tables. Let it be 35 40 60 20 10 50 25 18 55 75 65 17 15 45 30 25. So I have to get the correlation between the two subjects, physics and mathematics. So let us prepare a table. First column is student column, second column is physics column, let it be test A. Second column is mathematics column, third column is rank of physics column, fourth column is rank of mathematics column, fifth column is rank difference, and sixth column is difference square. Here I can change this order in such a way that physics score, and adjacent to this column we can put this rank column also, so it becomes easier. So as you wish. In the next example, I will take in such a way that score of one subject, and adjacent to this column I will take the rank of that subject, thereafter the second subject score and rank of that subject. Now come to the point. First we will prepare the table for physics score rank. So in this physics test, the student third has scored the highest marks, so I have put rank 1. Now the second highest score is 50, which has sixth number student has scored, so put 2 rank here. Third rank holder is student number 2 that has scored 40 marks, so put rank 3. Thereafter 35 marks, so put rank 4. Thereafter 25 marks, putting rank 5. Thereafter 20 marks, putting rank 6. Thereafter 18 marks, putting rank 7. And the lowest mark, that is the 8th rank holder is student number 5, so I have given him the rank 8. So now it becomes easier to get that the rank is selected correctly, because since there are 8 students and 8 ranks are allotted, so that is correct. Now next is prepare a table for rank for mathematics students. In mathematics students, student number 2, which has scored highest score, that is 75 marks, so put rank 1. Thereafter 65 marks, putting rank 2. Thereafter 55 marks, putting rank 3. Thereafter 45 marks, putting rank 4. Thereafter 30 marks, putting rank 5. Thereafter 25 marks, putting rank 7. Thereafter 17 marks, putting rank 7. This rank is 7. And thereafter the last one has scored 15 marks, so rank 8 is given to this student. Okay, now next column is difference in rank. 4 minus 3 is 1, 3 minus 1 is 2, 1 minus 2 is 1, 6 minus 7 is 1, 8 minus 8 is 0, 2 minus 4 is 2, 5 minus 5 is 0, 7 minus 6 is 1. Difference means, suppose in this case 2 minus 4 is minus 2. So whether you consider this difference sign does not matter, the negative sign. Means all difference is taken, subtraction is there, but negative sign is not taken. If I will be taking the negative sign, then okay, no problem is there, because when the difference square is taken, the negative sign, the square of the negative sign becomes positive. 1 square is 1, 2 square is 4, 1 square is 1, 1 square is 1, 0 square is 0. Here if I am writing minus 2 square, then it becomes 4, or difference, taking difference, even though 2 square is 4, 0 square is 0, 1 square is 1. Adding all these values, difference square d square 1 plus 4 5, 5 plus 1 6, 6 plus 1 7, 7 plus 4 11, 11 plus 1 is 12. So sum of d square gives the summation d square, which is equal to 12. Now here there are 8 students, so n is equal to 8. N is equal to 8. Now using these two values, n is equal to 8 and summation d square is equal to 12, substituting these values in the equation given below. The equation is rho is equal to 1 minus 6 multiplied by summation d square divided by n within bracket n square minus 1. Putting summation d square is 12 and n is equal to 8. So rho is equal to 1 minus 6 into 12 divided by 8 within bracket a square minus 1. 8 square is 64. So rho is equal to 1 minus 6 multiplied by 12 divided by 8 within bracket 64 minus 1. 8 square is 64. Cancelling 4 2s are 8 and 4 3s are 12. So we have rho is equal to 1 minus 6 multiplied by 3 divided by 2 into 64 minus 1 is 63. Now again table of 3, 3 1s are 3, 3 2s are 6 and 3 1s are 3. So rho is equal to 1 minus 3 upon 21. 3 upon 21. So dividing 21, 3 upon 21, 21, putting decimal, 3, 21 ones are 21, remainder is 9, putting 1 0, 21 fours are 84, remainder is 6, 21 twos are 42, remainder is 18, putting 1 more 0 because there is a decimal. So 21 8s are 168, remainder is 12 and so on. So value of 3 by 21 is 0.1428. Now subtracting this value from 1, here I have written 1.00 minus 1.43. Since this value is more than 5, so preceding value increases by 1. So 1 minus 0.143. 2, this preceding value increases by 1. So 1.143. Now subtracting this, 10 minus 3 is 7, 9 minus 4 is 5 and 9 minus 1 is 8. So 0.857 plus 0.857. 0.857, again this value is 5 or more than 5, then preceding value increases by 1. So decimal plus 0.86. The correlation is found to be 0.86. Now interpretation. How we will interpret this result? The Spearman rank correlation coefficient between test A, that is physics, and test B, that is mathematics, is found to be plus 0.86. This indicates a high positive correlation. Very high positive correlation. Therefore, it can be said that students who perform well in test A, that is in physics subject, tend to perform well in test B, that is in subject mathematics. So very simple, we can say that those students are scoring good marks in physics, the same students are also scoring good marks in mathematics, and that's why such high correlation is observed. Again from data, look at the data. From data it is very clear. Suppose this student which has scored 60 marks in physics, highest score, again in mathematics he has scored 65. So in both the subjects he is doing well. Similarly, this student in physics scored 40 marks, in mathematics 75 marks. This student, 6 number student, has scored in physics 50 marks and mathematics 45 marks. Suppose the students number 4 which has scored 20 marks in physics and 17 marks in mathematics. So if he is poor in mathematics, he has been observed that he is also not doing well in physics. So from the data it is clear that the positive correlation is obtained. So very simple interpretation. In one subject, if the student of physics, if the student is doing well in physics, he is also doing well in mathematics. So this is the interpretation of the positive correlation. If in the suppose in the same example, if the negative correlation is observed, then we can interpret as the student who is doing well in physics but he is not doing well in mathematics. He is good in mathematics but he is poor in physics, might be possible. So negative correlation means this type of interpretation we will have to write, and in positive correlation we will write the interpretation like this. So this is all about this rank order method. In the next example I will take up, if the student are scoring same marks, then how the rank will be given. Means suppose this student has 60 marks and another one also has 60 marks, or this one student has 10 marks and one more student has 10 marks. So in part 37 I will cover, I will take up the example in which the students more or two or more students are having the same marks, then how the rank will be given. So this is all about this rank order method, in which I have solved one example. Please subscribe the channel, press the bell icon. Thank you.